Hi, so for today we're going to talk about the properties of limits and evaluating some basic limits. So this is a part of our study all about differential calculus. So let's get started. So we have some properties here. We have 7 properties that we're going to discuss here. Note that this is only a basic properties of limits and we will be evaluating limits that are really easy to evaluate. Okay, so as we go on further in our study of limits, we will be solving complicated limits and even all the topics involving limits. So let's get started. So for number 1, okay, we have the limit of c. This is read as the limit of c as x approaches a. Again, this is read as the limit of c as x approaches a is equal to c, where c is any constant number. Okay? And a is any real number, okay, real value, okay, we can substitute. So, if we evaluate the limit of a constant as x approaches a, that is only equal to the limit of, or to the constant itself. So, the limit of a constant value is the constant itself. Okay? So, for number 2, so the limit of x as x approaches a is simply a. So what will happen here if we evaluate the limit of x as x approaches a certain number, real number a, it should be equal only to what is the value of a. Okay? So that's property number 2. Limit of x as x approaches a is equal to a. So let's for the first problem, let's have an example. Okay? So it says for our first problem, the limit of a constant as x approaches a is simply equal to the constant. So, for example, if we have to evaluate the limit of 2 as x approaches 1, okay? So, this is a constant, this is our c, and this is our a. So, if we evaluate the limit of a certain constant, okay, as x approaches a, notice that there are no any x term here. So, it says by property number 1, whenever we evaluate the limit of a constant, that is considered, okay, that is equal to the constant itself, which is this. Okay, that's for number 1. How about for number 2? The limit of x as x approaches 2 is equal to what? So, the property that we have seen a while ago is this. The limit of x as x approaches a is equal to a. So, if we evaluate the limit of x as x approaches a, that is only equal to the a. So, in this case, we have an a that is equal to 2. So, if we have a function f of x simply equal to x and evaluate its limit, it should be always equal to the value of a, which is, in this case, 2. Okay? So, it's very simple for the first 2 properties. How about for the third property? The limit of a constant multiplied by x, okay, as x approaches a, is always we can factor out the constant outside of the limit and multiply it by the remaining f of x inside. So we have the c multiplied by limit of x as x approaches a is only equal to the constant multiplied by a, since this term is from the property 2. Okay, this whole thing is equal to the property 2. The limit of x as x approaches a is simply equal to a. So how do we apply that? Okay, so for example, if we evaluate the limit, okay, the limit of 2x as x approaches 2. Okay, so what we can do here is to rewrite this. We have a constant 2 here, 2 multiplied by the limit of x, okay, as x approaches 2. And if we evaluate this, okay, this has a similar property to our property number 2, wherein if we evaluate this should be only equal to, that's right, 2. We simply substitute the value of the a here in our x. So, 2 multiplied by 2 is equal to 4. That is what the property meant, okay, means. So, number 4, this is the limit of 2 functions f of x, g of x in addition and subtraction as x approaches a. Notice that we can distribute the limits such that we can evaluate first the limit of f of x as x approaches to a plus minus the limit of g of x as x approaches to a. Okay? So we can distribute the limits if we have a product or if we have sum and difference of the f of x. So let's try to have an example. We have the limit of 3 plus x. Okay? 3 plus x as x approaches negative 1. Okay? So first, since this is an addition, we can multiply this. Okay? But we can actually separate them. So we have the limit of 3 as x approaches negative 1 plus the limit of x as x approaches negative 1. So first, we can evaluate this left side. So we have the limit of a constant. This is a constant number. As x approaches negative 1, that is still considered as the constant itself, 3. Okay? And the limit of x as x approaches negative 1, this is our x, this is our a. If we have, again, an x, f of x only, we can simply substitute the value of negative 1. So the limit of this, don't forget the plus. We have the plus here. Okay? As x approaches negative 1 should be negative 1. So that if we evaluate this, this should be 3 minus 1. The limit that we are trying to find is equal only to 2. That's what this, same for subtraction. Okay? We only subtract the two limits. Okay, for number 5, the limit of f of x over g of x as x approaches a is the same. We can distribute the limit sign on the numerator such that we have the limit of f of x as x approaches a divided by the limit of g of x as x approaches a, given that the g of x or this denominator should not be equal to 0. Because if the denominator becomes 0, okay, we have an undefined function. Okay, so we have an undefined. So any number divided by 0, okay, we have an undefined. Well, of course, if 0 over 0, that's indeterminate form. So the rule is, if we are going to evaluate the limit of a, let's say we have a, what do you call here? A quotient, okay? A quotient. So we must avoid the denominator to get 0, okay? So to demonstrate that property, let me show you. To evaluate the limit of, let's say, 2 over x as x approaches 4, okay? So we can actually distribute the limit of 2 as x approaches 4 over the limit of x as x approaches 4. Okay, from our property, the limit of a constant is a constant itself. The limit of 2 as x approaches 4 is simply equal to, yes, that's right, 2, because this is a constant. Okay, and this, the limit of x as x approaches to 4, we simply substitute the value of 4 to the x. So we have 2/4, or in other words, we have 1/2. Okay, 1/2. So that's, we should avoid the denominator getting 0. Okay, for number 6, the limit of f of x raised to n as x approaches to a is simply equal to the quantity limit of f of x as x approaches to a raised to n, or if we have this kind of type of limit, okay, we can evaluate the limit L and we raise it to a certain number n. Okay, that is in the exponent. So for example, so if I want to find the limit of x squared as x approaches 2, okay, so I can rewrite this as the limit, the limit of x as x approaches to 2 squared. So if I'm going to evaluate the inner part, okay, the inner part, the limit of x as x approaches 2, that is simply equal to 2. Agree with me? Because that's what the property is trying to say. Now, don't forget that we have squared here. So we have 4. Okay? So we can always do that. Or we can actually directly substitute 2 here in order for us to evaluate the limit. No problem with that. Okay? So, but still, I'm going to show you the properties. So, lastly, for our number 7 property, the limit of the square root of f of x is, as x approaches to a, is simply equal to the square root, the quantity of the limit of f of x as x approaches to a, is simply equal to the square root of L, where L is the the result of the limit. So, let's try the limit of the square root of 2x as x approaches 2 is we can actually what? Have this, the limit of 2x, okay, as x approaches 2. So we can evaluate the limit of this, okay, the inside. So we know that if we simply substitute 2 here, we will be having, we can factor out 2 limit of x as x approaches 2. So we have now, as x approaches 2, that is square root of 2, limit of x as x approaches 2 is 2 times 2. Now, square root of 4 would become simply equal to 2. Okay, or we can simply substitute the value of a, okay, here inside the radical sign, okay, in our x, and evaluate the limit. Okay, so now let's try to solve some problems, okay, involving limits. Furthermore, okay, so we have the limit. Find the limit of x squared minus 4x as x approaches 2. Okay? So we have here a polynomial. So how do we evaluate the limit of this? Using the properties of our limits. Okay? By sum and product or sum and difference, so we have limit of x squared as x approaches to 2 minus the limit of 4x as x approaches to 2. Okay, so using the properties, we can have, okay, this limit, the limit of x as x approaches to squared. Okay, applying the property. Minus, I can factor out 4 outside of the limit because it's a constant. So the limit of x now would become x as x approaches to 2. So if we evaluate this, the limit of x as x approaches to 2, the inside of the quantity would become 2 because of the property. So we have 2 squared minus 4 multiplied by what is the limit of x as x approaches to 2. Simply, we substitute the value of 2 on the x by property. So we have 2. So that is 4 minus 4 times 2 is 8, and that results to a negative 4. Okay? So, another way to solve this, since this is a polynomial function, okay, this is a polynomial in our function, we can substitute directly the value of dx, okay, of the value of this a on our x function or our x term. So we can have 2 squared minus 4 times 2 is equals to 4 minus 8, and that is equivalent to negative 4. Okay? So if we have a polynomial, evaluating the limit of a certain polynomial, we can simply substitute the value of this a to our x's here. Okay? And that's the answer. So for number 2, let's try to solve again another problem. So the limit of, let's say, x cubed plus 2x squared minus 3x minus 4 as x approaches 1. So as what I have said a while ago, this is a polynomial. So we can simply substitute the value of 1, okay, in our x's here. So we have 1 cubed plus 2, 1 squared minus 3 times 1 minus 4. So we have a 1 plus 2 minus 3 minus 4. Okay, so our answer again is negative 4. So if you do the addition and subtraction properties such that you distribute the limit on every each term, on each term, you will still get the same answer. Okay, so let's try again for number 3. So for number 3, we have to evaluate the limit of 3x minus 1 squared over x plus 3 cubed as x approaches to 1. So what is our rule if we are evaluating a quotient f of x? The denominator should not equal to 0. Okay? So what we can do by our property, we can have the limit of 3x minus 1 squared as x approaches to 1 over the limit of x plus 1 cubed as x approaches to 1. Okay? So furthermore, we can have this as, we can simply substitute the value of 1. Okay? That is still the same if we try to include or rewrite this square outside of the parentheses. So we simply substitute the value of 1 for shortcuts. So we have 3 times 1 minus 1 squared. Okay, and the same for our values here. Okay, for 1. So we can simply substitute. So we have 1 plus 1 cube. Since this is a polynomial, okay, so we have 3 minus 1 is 2 squared, that is 4, over 2 cube, which is 8. 1 plus 1 is 2. 2 raised to 3 is 8, so that is 1/2 in its lowest term. So again, I didn't show you the whole process of properties, okay, because if we evaluate it, that is still the same, okay? So, if you don't believe me, let's try again. So, we have the limit as x approaches to 1 of 3x minus 1. Okay, oops. We should not have a parenthesis here. So, that is equivalent to square over the limit of x plus 1, okay, as x approaches to 1 of cube. Okay, that is still the same. Evaluate this. So we have the limit of 3x as x approaches to 1. Okay, let me just rewrite. The limit of 3x as x approaches to 1, that is a difference. So we have minus the limit of 1 as x approaches to 1 squared. Okay? Over the limit of x as x approaches to 1 plus the limit of 1 as x approaches to 1 cube. So if we evaluate this, we can factor out 3 outside of the limit. Okay? So that I can rewrite this 3 outside of the limit and multiplied by the limit of x as x approaches to 1. So that it would become 3 times 1, okay, because the limit of x as x approaches to 1 is 1, okay, minus the limit of 1 as x approaches to 1. The limit of a constant, 1 is the constant itself, which is 1, okay. And take note, this is in square. And we have the limit of x as x approaches to 1 is simply 1 by property again. And the limit of 1 as x approaches to 1, 1 plus 1, okay, because this is a constant. So, and the limit of a constant is the constant itself. So, as you can see, we have arrived at the same solution here to here. So, our answer in this is still 1/2. Okay? So, for next problem, we have number 4. The limit of 3 raised to x minus 3 raised to negative x over 3 raised to x plus 3 raised to negative x as x approaches to 0. Okay? So let me just rewrite this. I don't want to have any exponent that is a negative. So let's simplify that first. Limit of 3x minus, I can bring this down by actually negating and getting the reciprocal of this. So we have 1 over 3x, okay? That's by properties of exponent. As x approaches to 0, we have 3 raised to x minus plus 1 over 3 raised to x. Okay? And if we evaluate the limit of that, the limit of, this is by quotient, and we know that we have a restriction when evaluating the limit of a quotient. The quotient or the denominator should not be equal to 0 to avoid problems. So we have limits of 3 raised to x minus 1 over 3 raised to x as x approaches 0 over the limit of 3 raised to x plus 1 over 3 raised to x as x approaches to 0. Okay? So if we furthermore, again, evaluate the limit. So we have the limit of 3 raised to x as x approaches 0 minus the limit of 1 over 3 raised to x as x approaches 0 over the limit of 3 raised to x as x approaches 0 plus the limit of 1 over 3 raised to x as x approaches 0. Okay? So we can simply substitute the values of x's here. So we have 3 raised to 0. Okay? The values of a, I mean, to our x. So we have 3 raised to 0 minus 1 over 3 raised to 0 over 3 raised to 0 plus 1 over 3 raised to 0. And any number raised to 0 will be equal to 1. 1 minus 1 over 1. Okay, because 3 over 0, 3 raised to 0 is 1. Okay, and 1 plus 1 over 1. So we have 1 minus 1 over 1 plus 1, which is 0 over 2. So notice that we have a 0 denominator or 0 numerator. That's okay. We are trying to avoid only for the denominator to get 0. So 0 divided by 2, 0 divided by any number would be equal to 0. So that's the limit for this problem. Okay? And for number 5, okay? For number 5, we can have the limit of x minus 1 over x squared minus 1, okay, as x approaches to 2. Okay? So, the only problem here is, again, we should not get a 0 denominator here upon evaluating the limit. So, we can distribute the limit of x minus 1 as x approaches to divided by the limit of x squared minus 1 as x approaches to. And by properties, we can furthermore rewrite this as the limit of x as x approaches to minus the limit of 1 as x approaches to over the limit, okay, of x squared as x approaches to, okay, minus the limit of x or of 1, okay, of 1 as x approaches to. So again, the limit of x as x approaches to is simply equal to 2. The limit of 1 as x approaches to 2, this is a constant. So what? So the limit of a constant is always the constant itself. Okay, which is this. We have the limit of 2 as the limit of x squared as x approaches to 2. That is simply 2 squared, which is 4, minus the limit of a constant as x approaches 2 is simply the constant itself. So we have 1/3. Okay, so that is our answer. Or, from our given, we can simply first simplify the f of x before we evaluate the limit. Okay, as you can see here, limit as x as limit of x minus 1 over x squared minus 1. Okay, x squared minus 1 can be rewritten as x plus 1. Okay, x plus 1 multiplied by x minus 1. Okay, so as x approaches to 2. So we can see here that x minus 1 will cancel. So we have now the limit of 1 over x plus 1 as x approaches to 2. And we can simply what? Have the limit of 1 as x approaches to 2 over the limit of x plus 1 as x approaches to 2. As you can see here, if we evaluate that, that is the limit of 1 as x approaches to 2. The limit of a constant is the constant itself. So we have the limit of x as x approaches to 2 plus the limit of a constant 1 as x approaches to 2. So we have 1 over this, the limit of x as x approaches to 2 by property 2, that is equal to 2. The limit of a constant, okay, as x approaches 2 is simply the constant itself, which is 1. So we can have the same answer. Okay? So I hope that's clear with you. So for our next problem, for number 6, we can solve number 6, the limit of x squared minus 4 over x squared minus 5x plus 6, okay, as x approaches positive 2. Okay? So, we can, it's easier to evaluate the limit, okay? And since this is a quotient, we are actually avoiding for the denominator to get 0. Okay? So, for us to have an easier limit, So we can factor out this two polynomial f of x and g of x here on the denominator. So for us to have an f of x or function that is much simpler, therefore, if the function is much simpler, then we can evaluate its limit much easier. So we have the limit x squared minus 4 is equals to x plus 2, x minus 2 over, okay, over x squared minus 5x plus 6. If we factor that out, okay, if we factor that is x minus 2 multiplied by x minus 3. Okay, okay, that's correct. As x approaches to 2. As you can see here, okay, x minus 2 would cancel. So we are left with the limit of x plus 2 as x approaches to 2 over the limit of x minus 3 as x approaches to 2. So since these two are polynomials, so we can simply substitute the value of 2. 2 plus 2. And here we have 2 minus 3. So we have 4 over negative 1, which is negative 4. So that should be our answer for this problem. Okay? And again, another problem for that is that if we have the limit of x squared plus 3x plus 2 over x squared plus 4x plus 3 as x approaches negative 1. So, the only thing that we are avoiding again is the denominator to get 0. But since this is a polynomial function, we can simply substitute the value of a to our x's. So we have negative 1 squared plus 3 times negative 1 plus 2 over negative 1 squared plus 4 times negative 1 plus 3. But you can also, okay, you can also factor this out just like what we did on the previous example. If I'm going to solve this number 6, directly substituting the 2, we will still get the same answer. Okay? So I'm showing you the ways how to solve this. As long as the denominator should not be equal to 0. So negative 1 squared would be 1 plus 3 times negative 1, that's minus 3 plus 2, okay, over negative, okay, negative 1 squared is 1. So we have 1 minus 4 plus 3. So we have here 1 minus 3 is negative 2 plus 2, okay, that would be 0 on the denominator, and 1 minus 4 is negative 3 plus 3. Oh, we have an indeterminate form. So, there must be a way to solve this. Okay? So, we cannot allow this to happen. Okay? So, that is not the answer. We have a denominator that is equal to 0. If the numerator is the only one that is 0, then it's fine. So, it's an indeterminate. So, what are we going to do is, we should, what? We should factor or simplify this. Okay? Just like what we did here. Okay? So, if this answer appears, that is an indeterminate form, meaning that you will have to do something in this, in our function. So, if we simplify that, x squared plus 3x plus 2 is simply x plus 1 times x plus 2 over, this one is x plus 1, x plus 3, x plus 3, and x plus 1. That is still the same. So, as you can see here, this x plus 1 would simply cancel. Okay? Leaving us, we have the limit of x plus 2 as x approaches negative 1 over the limit of x plus 3, okay, as x approaches negative 1. So we can simply substitute here because this is a polynomial. So we have negative 1 plus 2 over, I'm doing the shortcuts, okay? And we have limit of x plus 3 as x approaches negative 1. That's negative 1 plus 3. So we have 1 over 2. And our answer is 1/2. Okay? So that should be our answer for evaluating this limit. So down to our second to the last problem here for our video. So we have number 8. Okay? So we have to evaluate the limit of the square root of z minus 2 over square root of, z minus 4. Okay. So the variable being evaluated function is not always in terms of x. It can be some other terms, okay, other variables, as z approaches 4. Notice that if we substitute directly 4, okay, 4 minus 2, square root of 4 minus 2 is 4 minus 4. So square root of 4 is 2 minus 2, 4 minus 4. So we would be having an indeterminate form. That we cannot allow that. So we must do something first, okay, in order for us before we evaluate the limit. So what are we going to do is that we are going to multiply the function square root of z minus 2, okay, over z minus 4 in the conjugate, okay, multiplied by the conjugate of the numerator. So square root of z plus 2, we would simply change the sign, over square root of z plus 2. Technically, this is equal to 1. Square root of z plus 2 over square root of z plus 2 is equal to 1. So multiplying it to our function would not do anything, but would simplify actually our function. Okay, this is still equal to 1. So it's still good to apply that. It's still valid to apply, to multiply that by this. So if we multiply this, what will happen? FOIL, first, square root of z times square root of z is simply z. Their exponents add up because we multiplied them. Outer, that is plus 2 square root of z. 2 times the square root of z, that's the outer. Inner, negative 2 times square root of z, that should be minus 2 square root of z. Negative 2, and last, negative 2 times 2 is negative 4. So as you can see here, 2 square root of z minus 2 square root of z would simply cancel. Okay? And we have on the denominator, let's not perform FOIL first on that. Square root of z plus 2. So that we still have that. So we have the limit of z minus 4 over z minus 4 multiplied by square root of z plus 2. The reason I did not perform FOIL on that is because we can, what? We can cancel this. Okay? So we have the limit of 1 over the square root of z plus 2 as z approaches to 4. So let's try to evaluate the limit. So the limit of 1 as z approaches 4 over the limit of square root of z plus 2 as z approaches 4. So the limit of a constant is the constant itself. So 1. So we have 1 over square root of 4 plus 2. So we have 1 over, square root of 4 is 2, plus 2, we have 1 over 4. Okay? So, I'm going to leave you a problem. You can solve this on your own. Okay? So, the limit of the square root of 2x plus 22 minus 4, okay, minus 4 over x plus 3 as x approaches negative 3. So, this is your challenge. This is your practice problem. I'm going to leave you with that. Evaluate the limit of that. And if you have already your answer, just comment down below on our comment section. And if you find this video helpful, don't forget to like or to comment down your comments. And don't forget, most of all, is to subscribe to my channel. So thank you so much. This is an introduction all about the properties of limits and evaluating the limits. Again, this is Engineer Abat, and God bless you.